Okay, in the first part we learned that the start point may not be 1 all the time, right? It can be you can start from 1 or you can start from 0, right? So for example, if you want to sum up r from 1, alright, just now I've already explained that if you want to make it start from 1, it's the same as if you want to start from 0, right? Because it doesn't matter. Alright, start from 0, you just plus 0, so the answer doesn't change. Okay. On the other hand, we also know that summing a constant is different. If you want to sum up a constant a from 1, it's not equals to, okay, summing up from 0 to n, right? Okay, because in this case a is a constant and the number of terms changes, right? As the number of terms changes, of course the answer will be different, right? Okay, so now we are going to explore what happens if the first term is not 1 and it's not 0? It's some other numbers, right? For example, 5, 6, 7 or 8, right? So there's a very useful formula that you can apply that's given by n summation. I want to start from a letter, right? M. Okay, M can be any numbers, right? Okay, let's say I want to sum up R from M to N, okay? And the formula is given by summing up R from 1 to N minus away summing up R from 1 to m minus 1. Okay, so the first term here is 1 and last term here is n. Okay, this last term will follow the last term over here, right? And this last term here will be the first term here minus away 1. Okay, I know a bit confused about how this formula works, so let me explain to you more in detail. And so let us draw some balls to illustrate this, right? Okay, so let's say this is the first term here, r equals to 1. This is the second term, r equals to 2. And okay, this is r equals to m. And the previous term will be m minus 1, right? Okay, and the previous term will be okay, and you sum up all the way until n, okay, r equals to n. Alright, so you look at the question, right? I want to sum up from m to n, right? That means this is what you want, right? You want to sum up from m all the way until n, right? So you're summing up from here all the way until here, right? Okay, so this is summing up from m to n, right? Okay, so it actually goes to summing up from 1 is the first term, right, to n, the whole thing. Okay, summing up from 1 to n, okay, minus away the first part, right? The first part is given by the sum from 1 to m minus 1, right? Because this is the term before m, so it's m minus 1. Okay, so this is how the formula works, right? So if you want to sum up from m to n, it's actually the summing from the first to the last minus the first to the previous, the one before the m term. Okay, so with this in mind, this formula is very useful now, right? So you can actually apply this formula to solve more questions. So say for example, I want to sum up from, in this case I want to sum up from 5, right, all the way to n, right? I want to sum up 5 to n. Okay, so in this, remember the formula, right? The formula only applies for 1 and 0, right? Okay, let me write the formula here again. It's actually n over 2 n plus 1, right? I covered this in the previous part. And this formula only applies for 1 and 0. Okay, in this case the first term is a 5, right? So let's apply the formula over here. Okay, I want to make it start from 1. Okay, so you'll get summation from 1 to n minus away the summation from 1 to the previous number, right? In this case it's 5 minus 1, so in this case it's 4. This thing can come here. Okay? Okay, so from 1 to n, you can simply sum in the formula. It's just n over 2 n plus 1, right? Because this is the formula over here, right? And from 1 to 4, you basically substitute 4 into the n over here. Can you see? Alright, so you just 4 over 2, 4 plus 1, so it's 5. Okay, and of course, if you simplify this, you will get n over 2, n plus 1 minus 2 times 5 is 10. Right? You will get, this is the answer, right? For this summation over here. Okay, so in conclusion, this formula is very useful when you want to make sure the starting point is a 1 or 0, right? If you want to change a starting point, right? Of course, if this is 0, then this will be 0 over here, right? Okay, and with this formula, you'll be able to solve more types of sigma notation.